It will either absorb ink or water by the action of surface tension. Every single layer will oppose the motion of the other layer. Some ratio with respect to distance is called gradient. They will not allow the layers to flow easily. Tangential destroying force is developed. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Let us continue the discussion on mechanical properties of fluids, and in today's class I will discuss something called as capillarity action and the property of viscosity of fluids. Now, to begin with, let us try to understand what is the meaning of capillarity, how actually this capillary action takes place. What is a capillary tube? To begin with, a tube of very fine bore is called as a capillary tube. So, suppose we have a tube of fine bores. Bores andre openings anta artha. So a tube of very fine bore is called a capillary tube. Now, when a capillary tube is dipped vertically in a liquid, suppose I dip this capillary tube vertically in a liquid, the liquid will rise if the angle of contact is less than 90 degrees. So there will be a sudden rise of liquid in this capillary tube if the angle of contact is less than 90 degrees. And there will be a sudden dip if the angle of contact is greater than 90 degrees. This sudden rise or fall in the level of a liquid inside a capillary tube due to surface tension is known as capillarity. So understand, students, when we are talking about a capillary tube, it is a very fine bore, very fine opening in a tube, which is called as a capillary tube. If you immerse the capillary tube vertically in a vessel containing a liquid, there is sudden rise of liquid inside the tube. if the angle of contact is less than 90 degrees. And there is sudden dip in the level of liquid in the tube if the angle of contact is greater than 90 degree. This rise or fall in the level of a liquid, either the rise or fall depending upon the angle of contact, is what we call as capillarity, or this is what we call as capillary action. Now, when we come to the applications of surface tension, due to capillarity action, water from the stem of the tree reaches every other branch of the tree. Basically, because of the capillarity, water is transferred from the stem of a tree to every other branch of the tree. Mosquitoes breed on the surface of stagnant water due to surface tension. A sheet of blotting paper you have seen, ink processor. A sheet of blotting paper contains fine pores. It absorbs ink or water due to surface tension. That blotting paper will have fine pores in it. It will either absorb ink or water by the action of surface tension. Raindrops are spherical in shape due to surface tension. Usually ask for 1 mark. Raindrops are spherical in shape. Why? And the answer is surface tension. So raindrops are spherical in shape due to surface tension. Oil lamp, it sucks the oil, again due to surface tension. So these are the various applications of surface tension. Now students, we study another important property of fluids called as viscosity. Jelly-like behavior of fluids, what we term as viscosity. Suppose when we cut a jackfruit and try to peel it, we feel the fruit sticks to our hand, viscous. We say kerosene oil is viscous, something sticky. And both the states of matter, that is liquids and gases, exhibit the property of viscosity. And we say liquids are more viscous than gases. Both liquids and gases exhibit the property of viscosity, where we say liquids are more viscous than gases. Now, what is this viscosity? We consider different layers of a liquid. Suppose I say this is the first layer, the second layer, third layer, and so on. There is a fluid which is flowing, and these are the different layers of that fluid. Now, understand, students, each layer will not allow the other layer to flow easily. Every single layer will oppose the motion of the other layer. The second layer of fluid will oppose the motion of the first layer. The third layer of the fluid will oppose the motion of the second layer. So thereby, if you can observe, every single layer will oppose the motion of the other layer, and this property is called viscosity. So viscosity is the property of a liquid wherein every single layer will oppose the motion of the other layer, because of which we have a tangential force that will create a relative opposition to the motion of the fluid. Each layer is opposing the motion of the other layer. Therefore, there is a tangential force developed which will destroy the nature of motion, which will destroy the relative motion between the layers, and that is called viscous force. Now, viscous force depends upon two parameters. First, area of the layers in contact, and something called velocity gradient. V is the velocity of the first layer. V plus dV, velocity of the second layer. Because of the opposition to motion, there is change in velocity with respect to distance. That is called velocity gradient. Some ratio with respect to distance is called gradient. So we say the viscous force depends upon two factors, two parameters. The first one is the area of the layers in contact, and then velocity gradient. Therefore, we write F is proportional to A, F is proportional to dV by dx, And removing the proportionality, we introduce a symbol called eta, where eta is called coefficient of viscosity. What do we call? Eta is coefficient of viscosity. And here the negative sign shows the viscous force acts opposite to the direction of motion. So F is the viscous force, eta coefficient of viscosity, A area of the layers, dV by dx velocity gradient, and very clear the viscous force is negative to the motion of layers, opposite to the motion of layers. Now, if area is 1 meter square and dV by dx is 1 meter per second, then eta becomes equal to F. Come and see. Observe. If A is 1 meter square and dV by dx is 1 meter per second, eta becomes equal to F, which means coefficient of viscosity, eta, is defined as the viscous force acting tangentially per unit area of a liquid having unit velocity gradient. So eta is nothing but F. Coefficient of viscosity is nothing but the tangential force which acts on a liquid of unit area moving with a velocity gradient of 1 meter per second or perpendicular to the direction of flow. And the SI unit of viscosity, Newton second meter minus 2, or kg meter minus 1 second minus 1, which is also called decapoise or Pascal. So remember, students, viscosity is nothing but a property where each layer of the fluid will oppose the motion of another layer. They will not allow the layers to flow easily. Tangential destroying forces developed. And we have also spoken about the coefficient of viscosity. So in my next class, I'll turn up with the applications of viscosity. Until then, have a nice time. Thank you.